Okay, so today our chapter is solution. Okay, class 12 chapter number 1, solution, right? Basically in chemistry what we will do, we will refer to the NCERT and whatever short notes I am providing that you have to do. In solution chapter is a physical chemistry chapter. So basically here we have to focus, right? Because we are giving the exam, competitive exam. So we have to focus on the conceptual clarity and the formula. In the formula again two things come, that how we have to implement the formula and at what type of question, which type of formula you have to use. That is basically a physical chemistry. When you have all the conceptual clarity over the formula and the units, okay, units are also very important. You can't use liter with ml, you can't use ml with liter. In molarity you have seen that, like in the mole concept chapter you have heard about molarity, you have heard about molality. In molarity, volume of solution is in liters, you can't use their ml. We will see one by one, so don't worry. But just here I am giving an insight that you can't use a different unit in the specified formula. If there is a liter, then you have to use liter. If there is ml, then you have to use ml. Okay, so these are the few things you have to keep in your mind when solving physical chemistry questions. Second, don't go into the theoretical loop of the chapter. Okay, so like this, if this is a 30-page chapter, so don't go into the loop of I will learn one by one word here. They won't ask. In physical chemistry chapters you have to focus maximum on the numerical, like back exercise question, in text question, PYQ. Like this question you have to more focus. You will say, sir, but in physical chemistry also theoretical question comes. It is 10%. Focus on the 90% first. When you are done with your 90%, then focus on that 10%. If 15 questions are coming from the physical chemistry, then 12 question will be numerical, 2 to 3 question will be theoretical. So we can't deep dive into theoretical by leaving the that 12 questions. Okay, so we will start our chapter and we have to keep NCERT with you. I will also open here when I will need it, right? So when you will read the NCERT, how you have to read, like let's say we are going with here, right, solution. So first we will see what NCERT is telling to us and how you have to read it. Okay, so because you have to read it, because when you will read the NCERT by yourself, then you know that yes, these points are important for my exam and these points I can leave it. How you will read, I will show. In normal life, we rarely come across pure substances. Most of these are mixtures containing two or more pure substances. So here what they are telling, now you have to stop here at this point. Most of these are mixture containing two or more pure substance. So here mixture is what? Which contain two or more pure substance. So pure, if you will add up the two pure substance, then you will get a mixture. So here it is telling the definition of the mixture. First point. Second, their utility or importance in the life depends on their composition. So we know that. So this line you can leave it, because we know that how the composition will be there in the mixture. The different type of mixture will form. Let's say if I am taking a rice and a dal, we will get a rice and dal. If I will cook dal in a different way, in a different composition, I will get a sambar. So there I will get a rice and a sambar. So here two pure things I am taking for a mixture, but it is in a different composition and its use case is different. So this we already know. So will you tag it? No. So I will not tag it. I will only mark this mixture containing two or more pure substance. This is my first point. Second, I will go for example the properties of brass. Now this can become in a theoretical question. How? They will ask you brass is a mixture of what? There you will say, sir, no, I don't know like this, but you have to read it. So brass is a mixture of what? Copper and zinc. Cu, copper, zinc, Zn. When I will mix Cu and Zn, I will get a brass. But again, if you have a mixture of copper, zinc, but I will also add a little bit nickel, then I will not get brass. Please remember, I will get German silver. Now you will say, sir, German silver doesn't have a silver. Where is Ag? Silver is denoted by Ag, right? Gold is denoted by Au. So please remember, whenever you are reading the book, it is not about just reading the book. You have to also know the elemental form, element number, atomic number, everything. We have a copper, zinc and nickel. When we have these three, I am getting German silver. When I have a copper and zinc, I have a brass. So two theoretical question you got here. Third, when I have a copper and a tin, then I am getting bronze. So these three theoretical questions they can ask in the match of the following or in a statement based question. Done. Next is what? 1 part per million, 1 ppm of fluoride ions in a water prevents the tooth decay. So 1 ppm of fluoride ion, again here, part per billion, no, part per million, yes. So here please focus on unit, ppm. So 1 part per million. You will say, sir, what is 1 part per million? Again, very simple. In 1 million, if you take a 1 part, it is 1 part per million of fluoride ions in a water prevent tooth decay. Please remember, of what? Fluoride. In which water? What it is preventing? Tooth decay. So very easy. Who using this? Dentists are using this. Very simple. While 1.5 ppm cause the tooth to become mottled and high concentration of fluoride ions can be poisonous. Now see how small change is there. 1 and 1.5. Very small change. You will feel, oh, what happens if I take 1.5 ppm? It will save my teeth more. No, it is poisonous. So these are the minute point you have to also keep into the focus. Now you will say, sir, how I will remember like this? If I will remember one line, it will take too much time. What is our goal? Read NCRT one time and final time. That is our goal. If I have to mark here, I will mark here one line. These three statements I have, two numbers I have here, its use case I have, this done. 3 points, this paragraph is done. Then again and again I will see only these lines. That's it. I will not read it one by one word. Okay, so this 3 point is done. And it is very interesting. If you are learning like this, it is very interesting. You will feel means like a game. Okay, so 1.5 is done. Poisonous is done. For example, sodium fluoride is used in rat poison. Okay, so 1.5 ppm is poisonous, I know. So can I use it in poison? Yes. Which poison? Rat poison. How much ppm? 1.5 ppm. Like this you have to tell. Reverse engineer. In the rat poison, what is used? Question asked in NEET exam. Let's say. Your answer will be yes, sodium fluoride 1.5 ppm. Done. In water containing salt at a particular ionic concentration, done. So that match with blood plasma concentration and so on. So here you got a use case of solution. Solution means what? When you are mixing, like mixtures are there. Now the another question in your mind will begin, that mixture can be of any type. I can mix a two liquid also, I can mix a liquid and solid also. So here the statement comes that types of solution which can be homogeneous and heterogeneous. Now at this point of time you already know that homogeneous means when we have a two component composition properties uniform, and if it is not uniform then it will be Heterogeneous. Very simple. So homogeneous we know, heterogeneous we know. Now do I need to mark this? No, I will not mark. I don't have that much time to focus on things which I already know it. So homogeneous I will not mark here. I know that yes, composition and properties will be uniform throughout. Solvent I know. One or more component present in the solution other than solvent are called solute. So what here they are telling about solute and the solvent. Please remember, solvent is in the largest quantity. Let's say you are taking a water and a salt. Salt is in large quantity or water is in large quantity? Obviously water. So water will be solvent. And what you are adding, it will be in one or more component. I can add salt also, I can add lemon little bit, and I can add sugar also. So what it is a solute. So if someone asks you what is solvent and what is solute, so you should remember it. What is in large quantity, it will be solvent. And what we have to add, that is solute. Solute will be always less than solvent. You have never heard of adding 1 kg salt into 1 drop of water. You never heard this. It is not a solution. Next is what? Binary solution. Also please focus on this bold text mark. Text. It is also very important. Binary solution, that is consisting of two components. Very simple. Binary means what? 0, 1. Binary means what? Two things. 2. So here if we have a 2 component, it will be a binary solution. Now you will say, sir, okay, I understood about everything, but what is a solute and what are the solvent? Please give an example. So this table is there, and this table is asked multiple times. So don't take it easy. Okay, I will read the table after my exam. It will not work like that. You have to read this table because question will be asked from here. And direct question comes. If the solute is gas, okay, first we will see types of solution. Okay, gaseous solution. Now very simple, I have seen students learning this also, but do you have to learn? No. See, gaseous solution. Okay, if let's assume if you have to make a gaseous solution, what should be the solvent? Obviously gas. Means what? A large quantity of a gas. Please, you when I am explaining, please little bit think in your mind a picture, right? There is a gas, right, and it is in very large quantity. Let's assume the air. Okay, in this air abundant volume of gas is present. In this gas I have to add a solute, right, like a salt in a water. Okay, solute. What I will do, I will mix a gas in the gas, right? What can be like this thing, like oxygen, mixture of oxygen. Oxygen is present in air, right? And let's assume I have a can of nitrogen gas and I have just opened the can and nitrogen and oxygen mixed together. Oxygen is already present in the air and nitrogen I have. So what happened here? Gas mixed into gas. But please remember that here gas will be solvent always because it is a gaseous solution. In the liquid solution, liquid will be solvent always. Solid solution, solid will be solvent always. When I am adding gas into the gas, I have the example, very simple. If I have a liquid into the gas, I have a chloroform. You have heard about the chloroform already. If you have a chloroform, what you will do? You will mix with the nitrogen gas and you are done. So what happened? Chloroform is liquid in nature, if you remember. Liquid is mixed with the gas. Done. Third is solid into the gas. You have seen the camphor naphthalene balls, right? So naphthalene balls, what it does, our mom keep into the cloth or anywhere where we know that rodents will come. So there we keep a camphor balls or naphthalene balls, let's say. What happens that naphthalene balls does, that is a solid in nature which diffuse with a gas in the environment. Okay, then we have a second liquid solution. Again same thing you have to do. Gas into liquid, liquid into liquid, solid into liquid. Gas what? Oxygen when dissolved in water. Liquid into liquid, ethanol in water. Solid into the liquid, glucose powder you have, right? You dissolve in the water. So we are done. Same here you are doing with gas into the solid. Now you will say, sir, this is new. I don't know. That gas into solid, how you will put? So solution of a hydrogen in palladium. There are some use cases here. Okay, it is a scientific use cases. Solution of a hydrogen in the palladium. Then we have a liquid in solid. How? Amalgam of mercury. If you have seen amalgam of mercury, search in the YouTube, you will get. It is in liquid. Sodium is what? Always solid. So amalgam of mercury is liquid. I am putting it into the sodium. So I am getting the solution of liquid into solid. Solid into solid. You will say, sir, how is it possible? Solid into solid is not possible, but it is possible. Copper is solid. Gold is solid. Copper dissolved in gold is solid dissolving in solid. So like this you are learning. Okay. Any doubt here?
No, sir.
Okay. Now what is the next point? Expressing concentration of the solution. Okay, we understood about the solution, we understood about heterogeneous and a homogeneous solution, we understood about binary solution when we are taking a two solution, we understood about the different composition will vary, like copper zinc is making something, copper zinc nickel is making something. Okay, so composition also depends. Next is what? We should know about the concentration of the solution. We have to express it. Either we are expressing it in mass percentage, either we are expressing it in volume percentage, either we are expressing it into molarity, molality, anything. So that we have to focus. So before going into here, okay, let's first complete this part, then we will write our short notes. Okay, expressing composition is done. Composition of a solution can be described by expressing its concentration. Okay, first mass percentage. From the name itself it is telling us mass percentage means what? Mass of the component in the solution upon total mass of the solution into 100. Percentage whenever will come into 100 will come. So from percentage, I already know 100 into will come. Whenever the percentage is coming, I have to divide it by total. So total mass of the solution will also come. And what total I have to use? Here from the first word it is telling us, which is mass. So mass percentage of a component is equal to mass of the component in the solution divided by total mass of the solution into 100. You will say, sir, is it done? No. Why it is not done? Because please remember, I will tell here, these things are not told many multiple times I have seen. Whenever you are reading the concentration, right, you have to not just mug up, not just rectify the formula. First of all, you have to understand, first point. Second point, what is the method of understanding the concentration is to read the example and to know that how we can write it into text format. You will say, sir, what it means writing into the text format. Read the below example, what it is. For example, if a solution is described by 10% glucose in water by mass, okay, So we will stop here. If a solution is described by 10% glucose in water by mass, here itself it is telling percentage, first point, by mass, second point. How much percentage? 10%. Glucose in water means what? Glucose is solid, water is liquid. Solid in liquid, is it solution? Yes. So 3 point we are done. As soon this you see, what you will write? Whenever you are talking about percentage, please use your mind that we are talking about total 100%, correct? From 100% only you will find 10%. So here you have to assume that you have 100 gram of a glucose. Okay, 100 gram, not a glucose, 100 gram of solution. Okay, 100 gram total you have. In that 10 gram is glucose. Then what will be remaining? 90 gram will be what? Water. Like this you have to understand. If you are writing into the textual format the same thing, same concentration, then you are good to go. If you are not able to do this, then you are still unclear with the concentration. 10%, if I ask you 10% glucose in water by mass, then you have to write there, yes, 10 gram of glucose, 100 minus 10 is what? 90. 90 gram of water. Now you can assume in your mind, okay, I will take a 10 gram of glucose, 90 gram of water, I will mix, I will get a 100 gram of solution. So everything is clear, because we don't have to exceed 100 gram, we don't have to go lower than 100 gram, because percentage is calculated on 100 value, right? So resulting in 100 gram of solution. Let's say they are written 30% glucose in water by mass. What it means? Said, tell. 30% glucose in water by mass.
It means that 30% of the total mass of the solution where the solvent is water is made up of glucose.
Yes. So how much gram is a glucose here? In 30% glucose in water by mass?
Sir, where is the mass of water in here?
No, don't see the mass of the water. Just tell, if here written 30% glucose in water by mass, correct? So,
Yes, sir.
so it means that 30 gram of glucose is there.
Yes, sir.
And what will be the water? How much?
Water will be 70 grams.
Good. So 70 gram will be water. So like this you have to write. Okay. Rest what Said told, that mass of the water, that where we have to use, we have to use later when we will calculate total, there we have to use, right? So it is also correct, but here what we are doing, here we are stating first, we are making the statement from the formula. If we are doing this to increase the conceptual clarity, because this is easy, okay, but later it will become hard. Okay, so this is done. Concentration described by mass percentage is common. So these are the theoretical things you can read little bit. Okay, so for commercial bleaching solution, 3.62 mass percentage of sodium hypochlorite in water is used. So simply you can remember industrial chemical application. That's it. Commercial bleaching solution. That's it. They will not, generally they don't ask so deep numerical statements in physical chemistry, but you can just go through it one time. Next is what? Volume percentage. Same thing again. Percentage means what? Into 100. Percentage means what? Divide by total something. But what total we have to do? Mass? No. Volume? Yes. So volume of the component divided by total volume of the solution into 100. Now again same thing, statement. What will be the statement? 10% ethanol solution in water. Here you have to stop. When you will read the NCERT again after this class, here you have to stop and you have to answer yourself. Okay. So 10% ethanol means what? 100 ml of what? 100 ml of solution will be there. In 100 ml of solution, 10 ml will be ethanol, 90 ml will be water. That's it. So means that 10 ml of ethanol is dissolved in water, total volume will be 100 ml. So water will be how much? 90 ml. Divide, minus, just subtract it. Solution containing liquids are commonly expressed in this unit. So they are what basically telling us, whenever you will use volume percentage, try to use in ml. Don't use liter. Okay, so try to use in ml. But you will say, sir, if I have to use liter, then what I will do? Just be sure that you are using liter here also and here also. But here if they are telling to express to use ml, so try to use ml. Let's say 1 liter here, 10 liter here. So write 1000 ml and 10,000 ml and then do into 100. Things will be same. It is not, until and unless you are using same unit above and below, then you are done. Solution containing liquids are commonly expressed in unit. Okay, for example, a 35% volume by volume solution of ethylene glycol. Now see, this question also come multiple times. Okay, this is what theoretical question. So what I am telling you, remember 1 okay, 1 example they are giving. Let's say mass percentage, remember industrial chemical application, bleaching solution. Here they are asking about antifreeze. What is the meaning of antifreeze? When the car, okay, used in the car for cooling the engine, right? What happens when we drive the car too much? Let's say they heat up a lot, so we have to use something to cool down the engine. That is called as an antifreeze. Okay, and this antifreeze is what? Ethylene glycol. And this ethylene glycol is 35%, so you don't have to remember the value. Just you remember ethylene glycol is called as an antifreeze. This question can come. And where it is used, this also question can come. At this concentration, the antifreeze lowers the freezing point of water to minus 17.6 degrees Celsius. So if you are too much frustrated to remember the temperatures, please remember this. We know that, okay, 0 degrees Celsius below the freezing comes. So minus 17.6, I will remember like minus 17, correct? Minus 17, if you multiply it by 2, you will get 35%. Done. Like this little bit tricks you can use. If you will multiply this by 2, you will get 35. Around. Third is what? Mass by volume percentage. Mass by volume percentage is what?
Molarity.
Molarity, correct. Mass by volume percentage is not molarity. Okay. Molarity is what? Again, tell.
It is the number of moles of substance present per liter
Right.
of solution.
Right. Good. So molarity and molality, always remember, here in both you have to deal with moles. Moles is denoted by n, small n. Okay. Here, are we talking about moles? We are not talking, right? We are talking about mass. So mass by volume means what? Here above, here we will use mass, and below we will use volume. From here, you are going to see the complexity level to increase. Another unit which is commonly used, where this is used? In medicine, pharmacy, mass by volume percentage. So it is a mass of solute dissolved in 100 ml of the solution. You have heard about, whenever you go to the hospital, you see there some solute, right? Some solute solid mass is dissolved into the 100 ml of NS solution. NS solution means what? Salt solution is there. They just put there, right? So what happens there? mass by volume. So if doctor asks to the nurse that how much you used there, so they will tell, sir, I have added 20 gram of 20 milligram of this solute into the 100 ml of the solution. So like this it is used, medicine and pharmacy. So what we have, three things we have, again repeating. So again and again if we repeat, it will go into our mind. Mass percentage is used in bleaching solution, volume percentage is used in antifreeze, mass by volume is used in hospital, medicine, pharmacy. Next is what? Parts per million. Very simple. When a solute is present in, very simple, see, one part in whole 1 million, you can think that it is a very trace quantity, very little quantity. So when a solute is present in trace quantity, it is convenient to express concentration in a parts per million, ppm. So ppm is equal to number of parts of the component upon total number of parts of all component of the solution into 10 to the power 6. Now you will say, sir, what is this 10 to the power 6? It is denoted by a million. That's why we are using 10 to the power 6. If we will use billion, then it will change. It will not be 10 to the power 6. So this point we have to remember that, okay, when if we are talking about million, we have to use 10 to the power 6. Here we will have a number of part. Which part it is? Trace quantity. Which part? Trace quantity. Divided by total number of parts of all the component of the solution. Done. Next. Again here we have the real life application. It can also expressed in mass to mass, volume to volume, mass to volume. Why this is happening? Because any unit will be above and below, it will cut. So at the end you will get a similar thing. A liter of a sea water which weighs 1030 gram contains about 6 into 10 to the power minus 3 gram of dissolved oxygen. Such a small concentration is also expressed as 5.8 gram per 10 to the power 6, 5.8 ppm of sea water. So how you can think a liter, only just 1 liter of sea water is having only such a small trace amount of dissolved oxygen. So rather than writing such a complicated term 6 into 10 to the power minus 3 gram in 1030 gram, better we will write into our ppm terms simply 5.8 ppm. Done. So for our easiness to write it down, we have found the ppm. The concentration of pollutant is also expressed in a ppm, mu gram microgram per ml. So here when we are talking about the pollutants in the water, there we are using the ppm. That's it. Next is what? Mole fraction. What is a mole fraction? Number of, again, number, first what it is denoted? Small x. From small x I will denote mole fraction. Okay, done. Now mole fraction, from the name itself, it is telling to us what mole fraction is mean. Mole fraction is what? Fraction. Fraction means what? Again, anything divided by total of something, correct? So number of moles of the component. Which fraction? Mole fraction. So number of what will be there? Mole. So number of moles of the component. Okay, done. But when we are getting into the fraction, total number we need at the bottom. Now you will say, sir, where is 100 into 100? Are we talking about percentage? No. We are talking just about fraction. So here I have to stop. So if I am talking about, let's say A and B I have taken, what I will do in this mixture? A moles is denoted by Na, B moles is denoted by Nb, and mole fraction of what they are asking, mole fraction of A they are asking, right? So mole fraction of A will be Xa is equal to Na upon Na plus Nb, correct? Now Rayan, tell me what will be the mole fraction of B? Rayan, tell what will be the mole fraction of B?
Mole fraction of X of B or X.
What?
Mole fraction of X of B, right?
Yes, mole fraction of B. B is your solute in the mixture, correct? It is denoted by, moles is denoted by Nb. Tell me mole fraction of B. What will be the B?
N of B upon NB plus NA.
What will be the nominator?
N of B plus NA.
Nb upon Na plus Nb, right?
Yeah,
Correct.
same.
Good. So what is the mole fraction of B here? Xb, okay, is equal to Nb, because I am talking about B. So mole fraction of what I will need? B. So Nb upon Na plus Nb. For a solution containing I number of component, let's say you don't have a 2 component, you have a multiple components. What I will do? Let's say this is only the question, mole fraction of A. So Xa is equal to Na upon Na plus Nb plus Nc plus Nd plus Ne, so on. Total. We need total here at the bottom. But here in the nominator, I need only what I have to find. That's it. Now it is very simple mathematics. Very simple mathematics. When I will add all the mole fraction, it will give me equal to 1. Let's say I have A and B here. What is my first step? I need to calculate Na and Nb. First step. Because without moles I cannot do anything. Or take C also. Nc. This is what? 2, 4, 6. Now I need a mole fraction of A. What I will do? Na means 2 divided by total. 6 plus 4, 10 to 12. Same here I will do. Mole fraction of B is 4 upon 12, and Xc here I will write 6 upon 12. Now when I will add these 3 together, I will get 1. 6 plus 4, 10 plus 2, 12 by 12 is 1. So this is the rule. Okay, this is the rule that when I will add all, right? Not, you can't say that I will add only Na, Xa and Xb and I will get 1. No. Each and everything you have to add. If you have 3 component, so you have to add mole fraction of all the 3, and then you will get is equal to 1. You will say, sir, where this will be used? So it will be used, let's say Xc is not given. They told you to find it. What you will do? You will add these two, subtract with 1 minus 6 by 12. 4 plus 2 is what? 6. 6 by 12, and 1 minus 6 by 12 is what? 6 by 12. So this is my answer of mole fraction of C. So such question can be asked. Not so simple question will be asked. Obviously these are the basic fundamentals. If these are clear, then only you will be able to solve. Then this question you got. Now whenever you will read this question, you will understand everything. Calculate the mole fraction. Now when I am reading the question, how I am reading? Calculate the mole fraction. I know, okay, into 100, I'll leave it into 100. They are not talking about percentage. They are talking about mole fraction. So I just need mole divided by total moles. That's it. Ethylene glycol C2H6O2 in a solution containing 20% of C2H6O2 by mass. Now see the complexity increased. Now the two things are there. I have to calculate mole fraction, but I got by mass. Means what? I got mass upon mass. So what I need? Okay, very simple. I will first write into textual format. That's why I was telling you. 20% means what? In 100 gram of solution. Now you will ask me, sir, 100 ml why not? 100 gram why you are telling? They are telling by mass. What is the definition of by mass? Mass upon mass into 100. So that's why I have to use total mass as a mass. And what is a mass? I can take kg? No, obviously not. For volume you have to take ml, and for solid you have to take gram. So 100 gram is my total solution. In that 20 gram is C2H6O2. Very simple. 100 gram I have total. Okay. In this 20 gram I have C2H6O2. So what remain? 80 gram. What it will be? What? Now you will say one more question. Now see how the questions are generating in our mind. This question comes to my mind when I was reading this chapter. Where water is written? How come 80 gram is assumed as a water? So there is a rule in the chemistry. When you are writing a solution and you are not defining what solution is there, you have to assume it as a water. Unified answer, water. Just keep water there. That's it. You don't have to use your brain until and unless written there. If they here written something, let's say written alcohol, okay, so there you have to use alcohol. If written any another liquid, then there you have to use that liquid. But here there is not written, so I will take 80 gram water. 20 gram is what? C2H6O2. Done. Now see the thing, how easy it is. I know that C2H6O2 is 20 gram. Can I know the total also? Total just calculate. Carbon 2 times into hydrogen 6 times into oxygen 2 times into. You will get a total mass which is 62 gram per mole. Why? Because it is a molar mass. Okay, 1 mole. Here we are talking about 1 mole. So that's why gram per. So this is what? Molar mass. So you got molar mass, correct? Now what will be our next step? Okay, sir, I got to know 100 gram. 80 gram is water, 20 gram is C2H6O2. I got total 62 gram per mole. Okay, done. Till here we know everything. But what we need to find? We need to find mole fraction. For the mole fraction of the ethylene glycol, I need moles of. First, now what I will read? I will write here mole fraction of ethylene glycol. Now I will write what I need, that I will find. Mole of ethylene C2H6O2, mole of C2H6O2 plus mole of water. These three things I need to find. I will just put it and I will get the answer. Next is what? Moles of C2H6O2. First I will find. So very simple. I know it is 20 gram. Total is 62 gram. So here I will just 20 divided by 62. Here I got 20 divided by 62. Done. Now I need water. Water I know already. I have 80 gram. And already I know that 18 gram is the total molar mass of the water. H2O. Just add. Right? H2O. Oxygen is 16. Hydrogen is 2. 16 plus 2 is how much? 18. So this is what? 18 divided by. Total is how much I have? 80. So sorry, here no, 80. 80 divided by 18. So what you have to keep at nominator, and its molar mass you have to keep it as denominator. Then only you will divide, obviously. Then only you will get your moles. Just put it here and you will get your easy answer, which is 0.068. That's it. If they ask you the mole fraction of a water, how you will find? Tell, Anaya, tell me. If here you are at this step, right? 0.068. Now they ask you in the second question, please find the mole fraction of the water. How you will find?
So you have to minus with 1 and the value of X glycol.
Good. So you don't have to write all this thing, you will minus, subtract, plus. Don't do this. Just 1 minus 0.068. Because here we have two things only, you can do it. But let's say if you have three things, then you can't do this. You have to use this method only. So use your mind little bit. Okay, if I have every value except 1, so then I can use simply 1 minus 0.068. I will get directly the value. If you have not the all values, then you can't use this. Okay, so this is the point. Now next is what? Molarity. Molarity is what? Molarity is M, denoted by capital M. Molality, L-I-T-Y. Molality is denoted by small m. So capital M is small m. Two different things. Capital M is defined as number of moles of a solute above volume of a solution in liter. Very important, in liter. Don't use ml. If you have ml in your question, convert it into liter. You don't have any other option. So molarity, capital M, is equal to moles of solute divided by volume of solution in liter. Done. For example, 0.25 mole per liter or 0.25 capital M, molarity, right? Solution of NaOH means that 0.25 mole of NaOH has been dissolved in 1 liter or 1 cubic decimeter. Now see what they are telling us. How I will read into textual format here? 0.25 moles of solute. Solute is what? NaOH. What I have told, if you have here written solution of NaOH, this will be obviously a solute, not solution, solute, not solvent also, solute. So 0.25 mole of NaOH done has been dissolved in how much liter? 1 liter. How much liter? 1 liter. 1 liter is also called as 1 cubic decimeter. Please remember, such question also come in exam. They will write in 1 cubic decimeter and student thinking, oh, how I will convert it into 1 liter, I don't know the conversion. You don't have to convert. 1 cubic decimeter is equal to 1 liter. If let's say cubic centimeter is there, then you have to convert it into cubic decimeter. So focus on the conversion, very important. In physics also, in physical chemistry also, organic, inorganic, everywhere. Now see the question, very simple question. Now we understand everything. Calculate the molarity of a solution containing 5 gram of NaOH in 450 ml of solution. We are done. Molarity we have to find. 5 gram given NaOH will be what? Solute. 450 ml is what? Solution. Very simple. 450 ml is written. I have to convert into liter. Immediately convert it into liter. First point. Now I have to find molarity. I got 450 divided by 1000 in liter, right? So I got a lower denominator. I need a nominator. Nominator is what? Moles of solute. What is a moles of solute? 5 gram of NaOH is written. So what I will do? 5 gram of NaOH. How I will find? 5 gram divided by NaOH, whatever will be the total molar mass of NaOH, that I have to put here. So it is 40, I think it's 40. So 40 is there. So 5 divided by 40. Here you will get answer 0.125. So I got answer 0.125 divided by 40. What is written here? 450. 450 ml, right? Can I use ml here? No. So I have to divide it by 1000 to make it liter. So 0.125. This 1000 will go above. 1000 divided by 450. And when you will get your answer, you will get 0.278 molar. Molality. Molarity, right? Not liti. Riti. Molarity. If you have to write here in the unit term, how you will write? Mole per liter. But I told you that you can write in cubic decimeter also. So mole decimeter, cubic decimeter, cubic decimeter. Mole. 0.278. Now next is what? Molality. Same thing you have to again repeat. Nothing new. Molality means what? Small m. Moles of the solute per kilogram kg. So here again you are writing moles of the solute. Here also you have moles of the solute. But here game changes because at the denominator you have mass of solvent in kg. Now this thing is very very important to understand. You have, let's say, NaCl and you have water. Now Saeed, tell me that when we are calculating the molality, right, mass of the solvent in kg means what? I have to use NaCl. First option is NaCl, second is water, third is solution, means both NaCl plus water. Tell me, Saeed, in the denominator, which mass I have to write here?
Water, sir.
Correct. This is the point you have to, very good. This point is missed by many students. In attempting the question, to attempt it fast, we forget many times that we have to use their solvent, not solute, not solution, solvent. What? In which unit? Kg. So for example, 1 mole per kg is, or 1 small amp. Here it is not a meter, it is a moles, molality. Okay. So molality. So 1 molality solution of KCl means that 1 mole of a KCl is dissolved in 1 kg of water. Now you will say, sir, where water written? So we have to pre-assume ourselves that water is a solution. Solvent, sorry. Water is a solvent. If it is not written, you have to assume by yourself that water is a solvent. Each method of expressing concentration has its own merit, demerit, mass percentage, mole fraction. Yeah, this is very important. Very important, missed by you also have not heard in school also. Very important. Question comes from here. Mass percentage, ppm, mole fraction, molality are independent of temperature. Whereas molarity is a function of a temperature. What is this capital M? It is molarity. Why it is? Temperature dependent. Temperature dependent. And others like small m, molarity, mass by mass, means percentage by mass, or ppm is not temperature dependent. First of all, please understand what is the meaning of temperature dependent. If I increase the temperature here, this will also affect. If I decrease the temperature here, this will also affect. But here if I increase the temperature or decrease the temperature, here no effect will be there because it is temperature independent. But here it is temperature dependent, means if I switch, increase or decrease the temperature, here the molarity will affect. Why this is happening? How I will learn? How in the exam you will learn? In the exam, will you get confused? Possible. So how we will know? Very simple. We know that PV is equal to nRT. We know. Volume is always dependent on temperature. We know in lower classes. If the volume is dependent on the temperature, in any formula volume is there, then it will be temperature dependent. Do we have a volume in molarity? Yes. In the denominator, if you remember, volume is there in liter solution. Do we have a volume in the formula of molarity? No. It is kg of solvent, gram, no volume is there. In mass by mass, no volume is there. ppm, no, we don't have a volume here. So if there is no volume, no temperature dependence. Very simple. Not only molarity, I am telling you, universal law. Let's say you will go in future and do the PhD in chemistry. You are not going to learn one by one each and every, oh, this is temperature dependent, this is not, this is not a right way. Molarity includes the volume in its formula. If it includes the volume in the formula, you have to use your lower classes formula, that is PV is equal to nRT. Volume is dependent into temperature. That is to direct dependence. Now you will ask me, sir, how I will know that it is increasing, decreasing, how? That is also simple. If NCERT written, nothing written NCERT. This is because volume depends on temperature, that's it. But how you will see that dependence? Very simple. Volume is directly proportional to the temperature. Yes. If I increase the volume, the temperature will increase. If I decrease the volume, temperature will decrease. Now I have to write here molarity. Molarity is equal to, here volume is coming, correct? So molarity is inverse proportional to volume. Volume is directly proportional to temperature. So now see, if the question asks temperature increase, what will happen to molarity? How you will answer? Very simple. This concept will be used in your physics also, in physical chemistry also, in inorganic chemistry also. So please focus how you are going to solve such type of question. Increase the temperature. Temperature and volume is directly proportional. So volume is also increasing. If volume is increasing, this is inversely proportional, so this will decrease. If temperature is decreasing, volume will also decrease. This is inversely proportional, so molarity will increase. That's it. Now from on this point of time, whenever such questions are going to come in physics also, in physical chemistry also, in inorganic chemistry, or anywhere you have to use such thing.
कार का लाइट शुरू है.
So you have to use such concept. Next is what? We have the example. Calculate molality of 2.5 gram of ethanoic acid CH3COOH in 75 gram of benzene. So you will use molar mass of C2H4O2 12 into 2 plus 1 into 4 plus 16 into 2 60 gram. So here you are just using the molar mass. Then you will calculate the moles. Then you will calculate the mass. And then simply you will put the values and you will get a molality of C2H4O2. Simple. Now solve this in-text question as a homework and tell me that from the concept whatever we have learned today, right? Like what you have to do, first step, you have to just see and think in a textual format. First write, okay, 30 gram of CONO3 twice dot 6H2O in 4.3 liter of solution means what? 30 ml of 0.5 molarity H2SO4 diluted to 500 ml means what? So this you have to first write into the textual format and anything comes. Okay, here if you see ml is there, here also H2SO4 500 ml is written, 0.5 molar H2SO4 is given. Break it. Okay, break it. 0.5 molar H2SO4 means what? First break it. 30 ml is written, that break. 30 ml is diluted in which? 500 ml. Break it. So first break the questions into multiple part and see if you can able to solve. If you are able to solve 4 out of 5, then you are done. Take a help of in one question. That's it. Okay. So we will end the class today at this point and we will continue to our next part into the next class. Okay, any doubt here?
No, sir.
Okay. Okay, Anaya, Rayan, any doubt?
No, sir.
No, sir.
Okay, so we will end the class today and we continue into our next class.
Thank you, sir.
Thank you, sir. Bye, sir.
Okay, bye.